Hello, this is the SAT practice test number 6, and today I'll be doing module 2. This is the straight up practice test from the College Board website as of October 2024. If you're looking for module 1, that is in a previous video here on the Cinderella Math channel. So yeah, let's go ahead, jump in. Practice test number 6, module 2. You do want, scratch paper, pencil, your handheld calculator. Make sure it's on the SAT approved list. You can find that list at College Board website. And then I've also pulled up the Desmos testing calculator. So that's what you kind of want to have ready. All right, here we are to module 2. We do have some formulas here that might come in handy. And we'll just go ahead and jump right in. We have number 1, the function defined as f of x equals 8x. For what value of x does f of x equal 72? So all we need to do is say that 72 is the function value, and we're solving for x, which gives us 9. Probably a lot of you just do that in your head. That's fine. Moving on. We have some vertical angles. In the figure, 2 lines intersect at a point. They tell us that angle 1 and angle 2 are indeed vertical angles. The measure of angle 1 is 72, and we need to know that verticals are congruent. So, boop, 72. Done. Awesome. Up to number 3. On a street with 7 houses, 2 are blue. If a house from this street is selected at random, what's the probability of selecting a house that is blue? So there's 7 total. That's why all the denominators are 7. And out of those 7, 2 are blue. Looking pretty good here on this first page. Of course, it's going to get harder, but not bad so far. All right, coming on down to number 4. We have a graph of the function is shown below. Right? That is definitely a linear. That is a line. So coming down to the options, you could immediately get rid of C and D because this is not exponential. So if you had to make a guess, it's either A or B because they have linear. And then we're going to pick A because it's increasing. If you start on the left side, you're going up, 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 up. So usually we would say the slope is positive, but we could also say that is increasing, going up, 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 up. All righty. So that was A. Next page. Number 5. We have another linear function here. The graph of the function f is shown. What is the y-intercept? Okay, so coming down the y-axis, we want to see where it hits right here at -4. So over nothing, down 4 would be our y-intercept. Number 6. Oops, sorry. We have a system. The solution to the given system of equations is x, y. What is the value of y? Well, they've told you x is 8. So just pop that right there. So 8 plus 3y is 26. Solve. Minus 8 gives us 3y is 18. Dividing 3, y is 6. Now be careful, don't just put in 6. It's the point. Always x comma y. X was 8, y was 6. You could also do that on Desmos, and I'll show that now. I don't know if that's any faster, but I will show you that option. Okay, to do it on Desmos, we'd come over here, and in your first line, you would say x is 8, and then your second line was x plus 3y equals 26. So x plus 3y equals 26. And then you're looking for this intersection point, boom, 8, 6. So they're both pretty quick there because they gave us the x value. You could do it by hand or Desmos. They both get the job done. 8, 6. was that solution to that system. Up to 7. The amount of Hannah's bill for a food order was $50, and she gave a tip of 20% on the amount of the bill. What is the amount in dollars of the tip Hannah gave? Okay, so we're going to take her total times the tip. And so we're going to change this to 0.20, or 0.2 would be fine. And that's how much she tipped the server. So you can just run that through your calculator. $10. She tipped the server $10. Oops, not 110. 10. If it would have said what was her total, you would do 50 plus 10 and say in total she spent 60 at the restaurant. But it didn't ask for that. They just said the tip. So be careful because they could have asked for that. Which expression is equivalent to 5x to the 5th minus 6x to the 4th plus 8x cubed? So it looks like we're going to be factoring. Definitely looks like we have a greatest common factor. Just looking at the x's, he has 5, 4, 3. So in common, they all have at least 3. So we're going to pull out that greatest common factor of x cubed. That would leave 5, and he'd still have 2 x's, minus 6 with 1 x, and then plus 8, and then he has no x's. We've removed them all. We GCF'd that to the front. So that gives us option B. Really, we could have just found out it was B as soon as we pulled this just this x cube. Kind of didn't need to do the rest, but there we go. Number 9, the ratio of the length of line segment XY to the length of line segment ZV is 6:1. Okay, so we have some line segment XY and some line segment ZV, not drawn to scale, by the way. And the length is 6:1 in ratio, right? So 6:1. Or we can write it like this, 6:1. The actual length of XY is 102 inches. We want the actual length of this guy. That's how I would set up my proportion. And then I would cross multiply, giving us 6x is 102, dividing 6 and getting 17. So the smaller line segment ZV has a length of 17 inches. Okay, that was number 9. Okay, it's got to be, I'm trying to throw out one of the answers. It's definitely not 102. It makes no sense that it's the same. So you could at least eliminate that one. And then we're told that the first one is 6:1, right? So this one's bigger. This one's smaller. So then it has to be smaller than 102. So you know you can now get rid of D. So again, if you had to take a shot in the dark, you could at least get it down to a 50-50. But just set up your proportion, your ratio, and you'll get that. Which equation has the same solution? Okay, I'll do this by hand, and then I do think maybe it's worth looking at in Desmos as well. I'm going to divide the 7. 2x minus 3 is 9. Add the 3. Divide the 2. So x is 6. So we're looking for which other one has an answer x equals 6, because the question is same solution. So if we look kind of just process of elimination, if we look at A, going to add 3, divide 2, and that will do it. So we just lucked out that it was A. If it hadn't have worked, I would just keep going to B, C, and D until I find it. So that one is A. And again, kind of just got lucky that it was A. Or kind of not. because if we look up back to my original first step, I'm going to kind of start this problem over actually. We didn't really have to do all that work. If you look back to the original, when I divided by 7 to remove that, this was 2x minus 3 equals 9, which is A. So really didn't have to solve all that. Not that it hurt you, but under a time clock, it could hurt you. So if we could catch that right there, you could just say A and be done. The other option, and I don't know if this is any faster, but I will show it to you, is to go over to Desmos and let's type the original, which was 7, 2x minus 3 equals 63. And then we can see the answer is 6. That straight line coming down at 6. We just care about the x value. And then just start typing the choices. So choice A was 2x minus 3 equals 9. And you can see that's the same. So that's why A is correct. If you did B, just to see that that's not correct, 2x minus 3 equals 56, you can see that that line did not hit on top. So B is incorrect. So again, I don't know if this is really worth your time, but I wanted to show just in case. Coming to 11, we have a function f defined by f of t is 14t plus 9, gives the estimated length in inches of a vine planted t months after Tavon purchased it. Which of the following is the best interpretation of the 9 in this context? All right. So we do have a linear function. You could think of it like this. Y equals 14x plus 9. So that is a line. And if you think of it in that context, this is your slope. And this is your B, your y-intercept. So 9 is the y-intercept. And if you think of it in the graph context, that means we're going to start the graph right there at 9. So that point is 0, 9. Now back to the actual plant context. If the x or t is 0, that means time is 0. This is the height in inches of the plant. So at time 0, the plant was 9 inches tall. That's when you first bought the thing or you first planted it. So the choice that works with that is D. That is about the length of the plant when Tavon got it from, the plant store, the nursery, the Home Depot, whatever. That is the starting length, choice D. You didn't really need to draw all that. I was just kind of being thorough there. If you could get that without having to work off to the side, that's fine. Coming to 12. What is a positive solution to the given equation? Okay, so that thing's already been factored, and then our solutions are where these equal 0. So if you set this equal to 0, the 2 would come over, and that's x equals -2. Set this to 0, the 5 would come over, and that's x equals 5. Set this to 0, the 9 would come over and be x equals -9, and they're asking for the positive. The only one of these three that's positive is 5. Brian saves 2/5 of the $215 he earns each week from his job. If he continues to save at this rate, how much money will he save in 9 weeks? Okay, so 2/5 of the 215. So we need to figure out what he saves in 1 week. So let's do 2/5 times, right, of is multiply, 215. You can just use your calculator for that or by hand. That's 430 divide 5. So that's 86. That's what he's saving per week. So that's not the answer, but that's gets us started there. And now he's going to save that for 9 weeks. So we'll times that by 9. At the end of 9 weeks, he'll have $774. Answer. Okay, so that's if you didn't want to use a calculator, I would probably just roll this one through Desmos. I would say, okay, what is 2/5 of his 215? 86. And then let's times that guy by 9. And that's how much money he has saved after 9 weeks. 774. The end. All right, 14. A rectangle has an area of 155 square inches. The length of the rectangle, so let's let this be length. I do a cursive L so it doesn't look like a 1, is 4 inches less. So we're gonna have a minus and a 4 in the back. Then 7 times the width. 7 width. We don't know the width. And then we know the length is 4 less than 7 times the width. Okay, and the area is 155. You can go to the formula sheet on this one if needed, but you probably know that the area of a rectangle is length times width. So we're going to take this times this. I'm going to distribute 7w squared minus 4w, and that equals the area, 155. I'm going to bring this over to set this quadratic equal to 0. Okay, so there's our quadratic there. I don't think I'd solve this by hand. That doesn't jump out at me as being easy to solve by hand. So I would take that to Desmos, and we just need to change the w's to x's. So maybe we should have used x from the get-go, but it's fine. Just change those to x's. All right. And looks like we're coming in at answers of 5 and negative, ooh. Okay, so w equals 5 and negative 4.429. Okay, thank you, Desmos. And now, though, this is a physical object, right? This is a rectangle. We could grab a ruler or a tape measure and measure it. We're not going to measure a negative number. So we can get rid of the negative answer, giving us that the width is 5. And that's what they were asking. What is the width? So width is 5 inches. If they would have asked for the length, you would have just put this 5 back in. You would have done 7 times 5, so 35 minus 4, which is 31. They didn't ask that, but they could have. They just wanted the width. So it looks like a geometry problem, and it is, but it certainly did mix in some algebra there. All right. What is the median? So we need to know that median is the middle. And we want to go ahead and line these up from least to greatest. So it looks like we have 3 4s, 2 5s, a 6, a 10, and 18. Okay, so we want to find the middle. Low, high, low, high, low, high, low, high. So the middle would be between these 2 5s, which would be 5. Okay, you don't have to do that by hand. I will show you on Desmos. I don't know if it makes it any faster, but I will show you. Okay, we're going to create a list, which is capital L, and you're going to tell it list 1, because it is possible to run multiple lists at a time. That 1 automatically goes as a subscript. Equals, and then you're going to do a hard bracket. And then you can just type that list. It does not have to be in order. So it can be just straight what they gave us here. Let me see if it'll let me copy and paste. Oop. Okay. So it looks like I have an extra. Yay, it did let me copy and paste. Commas in between, it's telling us we have 8 things. And now we're going to come to the second line and tell it median of list 1. And there we go. Again, I don't know if that's any faster than doing it by hand, but it is an option. 16. Where is he? There he is. A right circular cylinder has a volume of 432. Please excuse my drawings. I'm not very good. Okay, so we have a volume. of 432 cubic centimeters, right? The area of the base, so this circle or the top one, doesn't really matter. The area of the base is 24 centimeters squared. What is the height? Okay, so you could look on the formula sheet for this. The volume of a cylinder is pi r square h. Well, pi r square comes from this circle. They've already told us that the base, the circle, is 24. So this part is 24. Then they've told us the volume is 432, and we're solving for h. Solve. So I'm just going to let my calculator do 432 divide 24, and that's 18. The height is 18. Okay. Again, you can use the formula sheet. If you didn't know the volume formula, it is on there. Okay. 17. How many distinct real solutions does the equation have? 17. So real, right? That means not imaginary. If you were to solve this, you would take the square root and you would take the square root. Because this is negative, you can do it, but you would get imaginary solutions. You'd get two. You'd get two imaginary solutions. But the question is, how many real? None. We'll have two imaginary, but no real. Line K is defined by y equals 7x plus an eighth. Line J is perpendicular. What is the slope of J? All right, so we have this line here. We need to find its slope. So y equals mx plus b, m. There we go. So our original slope is 7. The rule for perpendicular is you take the slope, you flip it, and you negate it. So the perpendicular slope, this is really 7 over 1, right? There's an invisible 1. Flip that, so 1/7, negate it. That will be the perpendicular slope. That's just something we want to have memorized. If it would have said parallel, those have the same slope. So we would have left it at 7. But perpendicular, you take the original slope, flip it, and negate it. You don't even really need to look at this 1/8. That's the y-intercept. He's really not helping you here. It's all about the slope. Okay. Number 19. The table shows the linear relationship between the number of cars, C, on a commuter train and the maximum number of passengers and crew, P, that the train can carry. Which equation represents this? Okay. All right, so the relationship between the cars and basically the people. All righty. I would just, well, trying to think of the fastest way. There's a couple ways you could attack this. I'm tempted to just go ahead and kind of process of elimination, plug in 3 for C, because that's cars. So if you did that, that'd be 55 times 3 minus, plug in here, 174. And let's see what that is. So just run that through your calculator. 55 times 3 minus 174 is -9. So A is looking like it'll work. Let's try the next value though. Let's put in 5 and then 284. So that's going to be 55 times 5 minus 284. So right through the calculator. That's -9. And if this last one works, we should be good to go. So 55 times 10 minus 559. And that's -9. So it's looking like A. All of those worked into A, and that is right. I don't think that's really kind of the formal way to do it, but I think that attacks it just fine. I'm just taking a quick peek at the answer key that the SAT provided. Yeah, that's certainly not the formal way to do it. I'll now show the formal way, even though what I just did worked fine. And if A hadn't have worked, I just would have gone on to B. And if B wouldn't have worked, I would have gone on to C. But here's now the formal way to do it. They do tell you this is linear. So we can pull out the y equals mx plus b. This is going to be x. This is going to be y. So our cars is x. So mc, oops, this is b, plus b. And our passengers is y. Okay. And then we can get the slope. I'm going to just take these first two. Slope is the second y minus the first over second x minus the first. So that would give us 110 divide 2, which is 55. So our slope is 55. So that's our m. We're going to put that right here. So passengers equals 55 car plus b. So we know it's going to be 55 with the C. So that gets rid of answer option C and answer option D. So if you had to just guess from here, if you're running out of time, you could at least get it down to a 50-50. And now let's pick your favorite point. I'm going to pick the top one and plug in to find the B value. So this is going to be our C and this is going to be our P. So 174 equals 55 times 3 plus B. 174 equals 165 plus B minus, and 9 equals B. So this gives us passengers is 55 per car plus 9. And then that's just not how they gave it to us, right? Looks like they moved the passengers over. So 55C minus P, and they moved the 9 that way, is -9, which is A. So that's the more formal way to do it. Again, I don't know if that's any faster, but they both, again, get the job done. 20. If 4 to the power 8c equals third root, cube root, of 4 to the 7th, what is the value of c? So this guy right here is really 4 to the 7/3, right? We can turn any root into a rational exponent, with the outer index always being the denominator and the inner exponent always being the numerator. That's just a rule. And that now equals 4 to the 8c. Since the base is the same, you can just ignore that and have 8c is 7/3. I'm going to times by the reciprocal, which is 1/8, and times by the reciprocal, which is 7/24. That does not reduce. That's just good old algebra 2 right there. Coming down to 21. The solution to the given systems of equations is xy. What is the value of 6 times x minus 2? Oof. Okay, I do think Desmos is the fastest way to do this, but I will do it by hand just for funsies here. See how this is the same? I'm going to change that to A. And then see how this is the same? And change that to B. So now I'm going to have A minus 4B is 117. And A plus 4B is 442. And then I'm going to add straight down. That'll give us 2A. -4 plus 4 will cancel out. And then adding straight down, we get 559. Dividing by 2, that's not going to be pretty. So that is 279.5. All right, plug that right back here. That was A. So 279.5 equals x minus 2. So I'll add 2. So that'll be 281.5 equals x. And then we need to pop that into here. So we'll have 281.5 minus 2. 6 times 279.5. Just let your calculator do that. And we get a final answer of 1677. We didn't actually need to find the B or the Y. That wasn't critical here in this choice. So yes, the answer is 1677. That's the by hand. You could also take this to Desmos. Let me see if it'll let me copy and paste again. And you're going to do just one at a time. Oops, wrong thing. There we go. Ooh, that didn't copy very good. -4. And then same thing right here. Do your second one. Is it Y minus or plus? Sorry, it's plus. Okay. All right, let's zoom out until we find those two lines and their intersection. There he is. And then here's your X. And the question was, what's the value of 6x minus 2? So we can just stay in Desmos and we can say 6 times that X value, which was 281.5 minus 2, and there's our answer. So that was probably faster, but again, they both worked. Alrighty. We're on number 22. We have a triangle, and we are told that it's a right triangle with angle B as our right angle. The length of side AB is 10 root 37. And the length of side BC is 24 root 37. What is the length of AC? So we're looking for the hypotenuse. This is a sneaky Pythagorean theorem, is all this one is. So in any right triangle, we know we can take the two legs, square them, and add them together equals the hypotenuse squared. So we have 10 root 37 squared plus 24 root 37 squared equals C squared. So you do 10 squared, which is 100, and then root 37 squared, this comes out of the root and is just 37. 24 squared is 576. And again, root 37 squared, this comes out of the root and is just 37. So this would be 3,700 plus, I'll let my calculator take care of that next one. 21312, there we go. Let's let our calculators add that together. So that is 25012. And then we're going to take the square root, which is probably not pretty. Yeah, it's not. The decimal's like 158.15, blah, 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 blah. So you could just run all the choices through your calculator and see which one matches, or we can bring that crazy number off to the side here and break it down. 25012. Okay, well, it's even. So I'm going to just divide by 2, which is 12,506, which is still even. Okay, I do have an odd there, so let's try a 3. That did not work. So not a 4, not a 5, not a 6. Let me try 7. Nope. Not an 8, not a 9, 11. Ew. I got it to be 13 and 481. This is probably not the fastest way to get this done. I'm going to try another 13. 13 and 37. And then he's prime, right? So it looks like we have a pair of 2s. So that's going to bond together, and a pair of 13s. Bond together. 2 times 13 is 26. And then this root 37, or the 37 did not have a partner. He'll go back in. Okay, there was a faster way to do that. That was kind of the straight up formal way. Here's another way. This is 10 root 37. This is 24 root 37. And this is we don't know. You could just ignore the root 37s. Since they're on both of them, just ignore it for a second. Let's pretend this is just 10 and just 24. So 10 squared plus 24 squared is x squared. 100 plus 576 is x squared. 676 is x squared. If you put this through the calculator, it is a perfect square of 26. So this is 26, but then they all had a root 37. Bring it back. Okay. The other option is to come to Desmos and let Desmos mess with the Pythagorean for you. So that was 10 square root 37, all of that squared, plus 24 square root 37, all of that squared. Okay, there's our answer. And then take the square root of that guy. And then it's ugly. And then just find the choice that matches that. So if you tried A, 14 root 37, that does not match. If you try B, that does match. So that honestly might be the fastest. It's just whatever is more comfortable for you. B. And 23. We do have an exponential function here defined by the given equation on 23. Alrighty. The function can be rewritten where p is a constant. Which of the following is the closest value to p? All right. So if you look at our original function, it's 1.84 to the power x over 4. We want to rewrite it like this. Yucky. Okay. Trying to think of, again, I think there's multiple ways to do it. Trying to think of the easiest. If you just rewrote this one, you could say that's 1 plus 0.84 to the x over 4, right? So you could also say that's the 4th root of 1 plus 0.84 to the power of x. But we don't want any roots or anything. We want the x all by itself. So how would we get rid of a 4th root? We'd have to take it to the 4th power. Yeah? Yeah. Okay. Sorry, I'm just kind of thinking to myself here. So if we take this original to the fourth power, oops, there. So originally, this number would have been 84, right? 84 over 100 would be 84 hundredths. But we had to take it then to the fourth power. So basically, we multiplied this by 4. We need to do the opposite and take this p, which was 84, and divide it by 4. Right? Am I just talking nonsense? No, that's not right. That will give you 21, which is not the right choice. That is not right. Okay, so I could see B being chosen as the wrong choice. Okay, let's start this again. Tricky, tricky. Oh my gosh, sorry. So we could say this is 1 plus 0.84 to the x over 4, which is 1 plus 84 over 100. And now instead of x over 4, couldn't we say this is 1/4 times x? That is x over 4. So we could say this is 1 plus 84 over 100 to the 1/4 to the x. Because you're allowed to do that, right? A power to a power is multiplying. Run this through the calculator. So I'm going to take that over to Desmos. So, because there's no x, that's just numbers. So we can do that. 1 plus 84 over 100 to the power of a 4th. And that is 1.16, blah, 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 blah. So this inner part is 1.16, blah, 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 blah. And you still have the x. There we go. Goodness. That gives you A. This is approximately 16 hundredths. We round it off. It does say to the, which is closest. There we go. Ooh, I do not think I explained that well. Let me try that again. If you got it, fast forward me. We can rewrite the original as 1.84 to the 1/4 times x, right? Because isn't this just 1/4 times x? That is x over 4. We're allowed to do that. So when we have a power and a power, we can do them like this. 1.84 to the 1/4 to the x. That's the power rule. You can put this through a calculator, and that's approximately 1.16 to the x, giving this to be 16. Ew, that's ugly. Doable once I got the hang of it. All right, just a couple more here, getting hard. The function is defined by blah, 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 where a and b are constants. In the xy plane, the graph of this function passes through the point -24, 0, and f of 24 is less than 0. Which of the following must be true? Okay, so we kind of get a little visual on this. It hits the point -24, 0. So that's the x-intercept. Okay. And it says f of 24 is less than 0. So when we plug in 24, we are negative. So 24 right here, we don't know what it is, but we know it's negative. Okay. And then a square root, if you think about the parent square root function, it goes like this. So we have probably flipped this somehow to go like, I didn't hit the point, but there we go. That's probably been flipped somehow. So if it's flipped over the y-axis, the b's got negated somewhere. Which of the following must be true? If you plug in 0, do you get 24? No, I don't think so, right? This would be f of 0. That doesn't look like 24. If you plug in 0, do you get negative 24? No, I don't think that has to be true. Does A have to be bigger than B, or does A have to be less than B? Well, we know if we plug in negative 24, we get 0. So 0 equals A root negative 24 plus B. In order to take a root, and we're not going imaginary, just straight up, we need this inside to be positive. So negative 24 plus B has to be bigger or equal to 0. So B has to be bigger or equal to 0. Okay, so B is positive. Oh, no, not 0. Add 24 over. So B has to be bigger or equal to 24. Okay, so I would say B is bigger. So I would go D. Let's see if that's right. It is right. And I'm looking at the SAT answer key. Yes, that was their reasoning. Okay. So I do think the little sketch was handy. I don't know if it was 1000% necessary, but I do think it was handy. Okay. 25. In the XY plane, we have a circle. What is the length? Oh, goodness. Okay. Let's draw a quick circle. We know our center here is HK, and we have 2 points on the circle. So A, which has coordinates of H plus 1, and K plus root 102. And then we also have some circle B, some point on the circle B, and then it says ACB, so C is the center. A to C to B is a right angle. What is the length of AB, this arc? Ooh, okay. So arc length is your degree times your circumference. So circumference is 2 pi r, and then your degree out of 360. That's probably on the formula sheet. If you want to go check, feel free. So we are told that this is a right angle. So our degree is 90. So we can go ahead and put that in. We don't know the radius. So we need to get that. So how far is it from here to here? So can't we just take the distance from this point in the middle to A? So distance, second x minus first x squared plus second y minus first y squared. Okay, the h would cancel and you'd get 1 square, which is 1. The k would cancel and you'd get 102 square, which is 102, root 102 squared, which is just 102. So you get 103, but then that's all under a root. That's your distance, which is the radius, is root 103. Okay. So now, how come there's no pi's in the answer? What is the length AB? All right, that's okay. So I'm gonna just do it my way, and then maybe I've made a mistake somewhere. I'll go back in a minute. So 2 pi, we have a radius of length root 103 times 90 over 60 could be 9 over 36, which is a fourth, right? So 2 times a fourth is a half pi root 103 So I would say pi root 103 over 2, which is not an option. So certainly I've made a mistake here somewhere. I mean, I'm tempted if I had to guess, I would guess C because it has a 103 and has a 2, but it's just they're not in the right order. Let's think on this one. It is A. Okay. I wasn't I was obviously wrong, but not some of it was okay. All right. They don't want the arc length. They want the length of A to B like straight up triangle like this. That's what it is. So all that the distance formula was correct and the radius is root 103. And then down here, this would also be another radius and all radii are the same, right? So this is also root 103. So if we draw this right triangle, the center's right here. Here's A. This is root 103. This is B. This is also root 103. And this would be our hypotenuse. So I guess I know my mistake was thinking that they wanted arc AB, but they want the segment length AB. So this is a sneaky Pythagorean theorem. A squared plus B squared equals C squared. So that'd be root 103 squared plus root 103 squared equals C squared. So this would cancel and just be 103. This would cancel and just be 103. So we're looking at 206 is C squared, root, and there he is. Okay, so whoa. Actually not that hard of a problem once you know what they're asking. So no arc length needed. Did have to pull out that distance formula, which I don't think distance formula is on the formula sheet. Let's take a peek real fast. I don't want to lie to you. No, I don't think so. So you need to have distance formula in your back pocket. I doubt it'll come up more than once because it's annoying, but we did need it there. Okay, last page. 26. The scatter plot shows the relationship between two variables, x and y, for dataset E. The line of best fit is shown. Dataset F is created by multiplying the y coordinate each data point by 3.9, which would be the equation of line of best fit for set F. Okay. Interesting. So if we just pick a couple points, let's pick some that are relatively smack on. So this would be like over 2 up 15. Just going to pick maybe 3 that are as close as I can get. The 1840. And then they're going to multiply just the y's by 3.9. So times this by 3.9, which will give 258.5. And then the 18 will stay, times this by 3.9. That's 156. And then might be a good idea to get the y-intercept. So that looks like it's like 0, 12. So that would now be 0 times 3.9. So 12 times 3.9 is 46.8. So there's our y-intercept. So y equals something something plus 46.8. So if you look, I think that would get you to either A or B. And I don't think we're changing the slope. So I think we're just going to keep the same slope, but you could just very easily slope like these two right here. second y minus first, second x minus first. So 46.8 minus 58.5 is like negative 11.7. And then 0 minus 2 would be negative 2. Divide that and you get positive 5.85 as your slope. That looks like it's going to round to 5.9. Looking at A. And I think that's what the original slope was. Up about 6. So, up about 6 over 1-ish. It's A. There might be a faster way to do that. Now I'm looking at the SAT answer. It looks like that's pretty much what they did. Once you got this y-intercept, the green one, you could at least get it down to A or B, and then you could just go from there. Okay, 27. In a given system of equations, R is a constant. If it has no solution, what is the value of R? Okay, I'll do this by hand, and then we might be able to whip this through Desmos as well. So looking at the first one, let's combine like terms. I'm going to bring this over. So we have 48x minus 64y minus 48y is 24. Combining like terms, that's negative 112. So we have 48x minus 112y equals 24. Okay. And then if we manipulate the second one, we could bring this over. So this would be 12x plus ry is an eighth. And if they have no solution, that means they are parallel. They will never hit. So looking right here, we want these lines to be parallel or have the same slope. Okay, so let's actually, I'm going to reconvert it back. Let's get the slope of each one. So converting this one, the x would come over. So negative 112y equals negative 48x plus 24. Divide by negative 112. I'm only going to mess with the slope. We don't care about this. Negative divide negative would be positive, and 48 over 112 reduces to 3/7. You can just use your calculator or use Desmos. So you'd have y equals 3/7 x, and then blah, 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 blah. We don't care. Slope is 3/7. Now the second one, I'm going to bring this over. So we have ry equals negative 12x plus an eighth. Again, the eighth, we don't care. We're going to divide by r. And so we have a slope here of y equals negative 12 over r x, and this needs to match. Negative 12 over r needs to match 3/7 because we're looking for parallel lines so that the system has no solution. So 3/7 needs to equal negative 12 over r. Cross multiply 3r. Cross multiply negative 84. Divide 3. And r is negative 28. Woo! Negative 28. Are they asking for r? R. Let me check that. Yes. Yes, indeed. Trying to think if you could have done it in Desmos. I think maybe, but I don't know if it would have been worth the time. Because you don't know R. I think you almost have to do that by hand. So the name of the game was No Solution, knowing that those would be parallel lines and knowing from geometry that parallel lines have the same slope. There we go. All right, this was SAT practice test number 6, module 2. I hope this was helpful. Hope you're having a great day, and I hope to see you again soon. Thank you, and bye-bye.